Okay, so today I'm going to be making some diethyl ether. There's not much to say about it, and let's just get started. I start by filling a flask with 150 milliliters of anhydrous ethanol. The ethanol doesn't need to be anhydrous, and you can use 95% ethanol as well. I just had a lot of the anhydrous version. I put the flask in an ice bath, and then add an addition funnel on top of the flask. I fill the addition funnel with 150 milliliters of concentrated sulfuric acid. I then open the valve and start dripping the sulfuric acid into the ethanol, slowly. The addition is pretty exothermic, so it's important to add it very slowly, otherwise you might risk boiling over the ethanol. Once all the sulfuric acid was added, I put the flask into a heating mantle and add a few pieces of broken glass. During the reaction, the solutions get very viscous, so a stir bar is not going to be able to work properly. The broken glass helps the solution to boil evenly. I then set up a distillation apparatus and an addition funnel on the left. The addition funnel is filled with another 400 milliliters of ethanol. An important thing to note is that the thermometer is placed directly inside the reaction mixture and not hovering above it. This is because we need to monitor the temperature of the reaction mixture and not the temperature of the vapors. I then turn on the heating mantle to a temperature of 140 degrees. It's important that the reaction mixture stays between 130 and 150 C. If the reaction mixture goes above 150 C, we won't form diethyl ether but will form ethylene. However, if the reaction stays below 130 C, the ether production is going to be extremely slow and inefficient. So 140 C is the perfect temperature. I also installed a fan on the left side of the apparatus to blow away any ether vapors. Ether has an extremely low autoignition temperature of only 160 C, meaning it's extremely flammable and can even be ignited by a heating mantle or a hot plate. I did seal all the joints with concentrated sulfuric acid, so there probably shouldn't be any leaks, but the fan is just in case. The collection flask was also covered in ice. Here's what's going on. First, an ethanol molecule is attacked by sulfuric acid, which protonates the hydroxyl group and it leaves as water. This forms a carbocation, which is attacked by another ethanol molecule, forming diethyl ether. The process then repeats with the sulfuric acid acting as a catalyst and keeping the mixture acidic. Once the temperature heats up and it reaches around 140 C, we start seeing some bubbles. These are diethyl ether. A weird thing that happens is that even though the temperature is much higher than ethanol's boiling point, the ethanol doesn't boil. This is because of all the sulfuric acid forming hydrogen bonds with the ethanol and keeping it from boiling. This way we're able to distill off the diethyl ether without losing any of the ethanol. Eventually the rate of ether production speeds up a lot and we start collecting many drops of diethyl ether in our receiving flask. Once the ether starts distilling over, we open the addition funnel and start dripping in the other 400 milliliters of ethanol at the same rate that the ether is distilling over. Right now the ether is distilling over at around 2 drops per second, so we adjust the same rate of ethanol addition. Adding the ethanol this way allows for a higher concentration of sulfuric acid in the reaction flask, leading to a better ether yield and a faster reaction time. In theory, we could add as much ethanol as we wanted. However, since the reaction produces water, the sulfuric acid is going to get more and more dilute, so the reaction is going to be less and less efficient. Once we've added all the ethanol and the ether stops coming over, I turn off the heat. I have around 450 ml of ether in the collection flask. This won't fit all into my separatory funnel, so I'll have to do 2 runs. So I add as much ether as I can into a separatory funnel, and then I add some saturated sodium bicarbonate solution. This helps get rid of any residual sulfuric acid that was distilled over. The amount should be very tiny, but acidic impurities tend to ruin ether over time, so it's a good idea to get rid of as much acid as possible. I then cap the separatory funnel and shake it around, venting frequently. I then drain off the lower aqueous layer, and I'm left with some nice and clean ether. I repeat this for all the remaining ether, and then I put it all into an ice bath. I add 50 grams of anhydrous calcium chloride to absorb any remaining water. I didn't show it earlier, but I also washed the ether with some saturated sodium chloride solution. It's important to use an ice bath when adding the calcium chloride, since the calcium chloride is going to cause the mixture to heat up a lot as it absorbs the water, which might cause the ether to boil. I then swirl it around to make sure all the calcium chloride is mixed in well with the ether. Then let it sit in the ice bath with the calcium chloride for a couple hours. I then distill off all the ether to further purify it. The final yield of ether was 200 mils. This corresponds to a 37% yield, which is pretty bad. This reaction typically yields around 70%. I actually had a pretty good yield of ether before purifying it and everything, but I think a lot of the ether evaporated. Ether is extremely volatile and boils at around 34 Celsius, and room temperature where I live is around 31 degrees. This means that the ether barely boils at room temperature, so a lot of it boils away when you're handling it. Ether is also pretty light sensitive, so I put it in an amber glass bottle and I stored it covered in aluminum foil. In the bottle along with the ether, I also added half a gram of potassium hydroxide and half a gram of butylated hydroxytoluene. Ethers in general are pretty annoying since they tend to form explosive peroxides when stored over time. The butylated hydroxytoluene helps prevent the formation of these peroxides, and the potassium hydroxide helps to keep the mixture alkaline and dry, which inhibits even more the production of the peroxides. All these precautions should help keep the ether nice and clean and peroxide free for at least 1 year.